Okay, now we will see some theory part. Okay, no problem. Here's a Linus Torvald. You can see here. This one is Dennis Ritchie. I had a confusion at the beginning. I was knowing this is the Dennis Ritchie, but I just wanted to confirm because both have beer and this is Dennis Ritchie. This particular guy is Thompson. This is again very strong guy. He's a Tannenbaum. How many of you are from IT or computer science? Please type IT or computer in the C in the chat window, I or C. And if you studied that networking or operating system subject, you might have read his book about it. This is Tannenbaum, and this is Richard Stallman. So let me give you the brief of Linux operating system, how it evolved over the period of time. So during 1960, in Bell Lab, somebody developed this multitasking operating system. After that, in 1970, again in Bell Lab, Dennis Ritchie developed that C programming language, and it is ported with his programming language, that is C, and it is being called as Unix. So many times you will see this interchangeably, Linux and Unix. So the origin is Unix. Again, both are same, but there are certain different provider when it comes to the Unix and Linux. Have you heard about mainframe? So mainframe uses this Unix operating system, while most of the places it is being Linux. So these two people, they come up with their own version and they name it Unix. After that, it caused portability. Portability means various hardware. This particular operating system was very easy to integrate. Means take the example of mobile. In mobile also you use Linux operating system. In various hardware, means it could be Dell or other hardwares. There also we use Linux, or even IoT devices. There also we use Linux. So it is portable operating system. Then during 1977, there was add-on, means they change something and uh, they come up with some commercial distribution of the Unix, and the leader were HP and IBM. They offer the commercial offerings of this operating system, and as it was commercial, means paid operating system. So Stallman, he started a movement, GNU movement, means not Unix. GNU is not Unix. That is the name of that movement. And what he proposed in that movement, he proposed that open source community environment where people are coming together, all great minds in software world, they are coming together and they're making all these softwares freely available in the market. So have you heard about Apache Foundation? One of the most popular foundation for open source softwares, Apache Foundation. So if you heard about big data technology, Hadoop, that is the blessings of the Apache Foundation. Okay, and there are many other projects as part of Apache. Even Kubernetes is a Apache Foundation project. And what is this Apache Foundation? If you see Yahoo, which is no more right now. So Yahoo was biggest contributor in Apache Foundation. Google is contributor. Facebook is contributor. Hive project from big data space is contributed by Facebook. LinkedIn has contributed Kafka and all other projects. So they are the contributor, all big people. And even suppose you have a good project and if you want to make it open source, you need to approach to the Apache community and they will review and they will make it open source also. So that is the power. And same fashion, this Richard Stallman, he started this movement where he wanted to make it free software movement. So we need to thanks to the Richard Stallman if you are using any free software. Then after that, Andrew Tannenbaum, he developed one book, or he had written one book about OS design and implementation. So from this book, this guy, Linus Torvald, took a inspiration after reading that book, and he started developing OS kernel. So again, note it down very carefully. Linux Torvald, he didn't develop the Linux operating system. There are many components when it comes to the Linux operating system. He has developed the Linux kernel. He's the originator of that Linux kernel. Till now, he manages that project. Okay. So Linus Torvald took inspiration and he developed the Linux kernel. And after that, this GNU component, I mean GNU movement, they had lots of other free software and they integrated with that kernel. And we got the new version of the Linux operating system during 1992. Okay. And after that, as it is open source community, right? Everybody take that project, they do their own customization, and there are various distribution of Linux operating system. Various means even if you want to take that code, make some changes as per your requirement, and you can also come up with your own distribution. So in Linux world we have various, I don't know exact count, but lots of distribution of Linux. But again, out of that, few distributions are very popular and we mainly focus on those distribution. And there is a commercial distribution also, that is REHL, Red Hat Linux. So that mainly people use for production environment. So that is about Linux. And then Linux is being used everywhere. If you see smartphones, even our Android operating system, it is a Linux operating system. Tablet, iOS base is also Linux, right? Then servers, IoT devices, as I told you, right? Then routers, even router which routes the IP packages here and there. Internally, it uses Linux operating system. And even smart cars, and we have driverless cars. There also we have Linux, and most of the server means it could be email server, yeah, file server. Everywhere we are using Linux operating system. So every day you see 10 patches, 7 days a week, and 24/7. So lots of patches coming and lots of development in the backend. So one of the most active project in current scenario. So till now, anybody any question on Linux history? This is quick history. There are many things I can talk about here, but so that is about history. Now coming to the some Linux basics. So Linux is multi-user. So in your Windows operating system also, we saw you logged in with certain user. At the same time, somebody also can log in same operating system, right? If it is remotely accessible. So that way, Windows is also multi-user, and in the same fashion, Linux is also multi-user, multitasking operating system. It is suitable for servers. It is one of the most popular operating system when it comes to the server, right? So desktop, we generally use Windows operating system, but very powerful servers are there in the world, and almost 99% servers are hosted on Linux operating system. That's where Linux is such a powerful operating system. And even it is scientist or NASA or our local computer science world where also this is very popular. Uh, then OS is all the programs that are required to operate a computer and monitor user program. So what is operating system in the short? So operating system means what? At the end, whatever you are doing on the computer, right? You are giving instructions to the hardware, right? Whether you are typing on the keyboard, you are reading data from the hard disk, right, or pen drive, or you are moving your mouse. So what you are doing, you are giving instructions to hardware, right? And whatever we see on the screen, that is handled through the software. So how that coordination happens between various parts of your hardware, we have very good diagram. So that's where operating system is very important. So at the base level you will have the hardware, and the next level you will have the kernel, and on top of the kernel you will have the shell, and on the top of the shell you will have various program or utilities. And that's how we send those instruction at the end to read the data from hard disk, to send the data into the memory, or reading data and displaying on the screen. So everything is taken care through some software in the backend, and that entire coordination happens via operating system. It is not just that, but various programs are running there, memory management, process management, right? All those things, processor, CPU allocation, all these things happens via operating system. Linux is made up of three parts, as I talk about, right? So base, we will have hardware, kernel, shells, and on top of that, we will have programs. I'll talk about shell also. Kernel of the OS is a component that assists the hardware and inter-process communication. Inter-process means, take example, hard disk is there, network interface is there, means we are reading data on browser, right? So that data goes on interface also, comes on memory also. So all these things are inter-process communication, right? So that is everything is handled via operating system. And this is what actually operating system. So here we have a hardware kernel act as a hub of OS, allocate time and memory to the program. Okay, so how much time is required, how much memory is required, so that is being taken care by the kernel. Shell comes on the top of operating system. So few minutes back we saw git shell, right? Git shell is again on top of git. As a software they created that shell, and using that shell we can run the command. So in case of Linux also we have various shells, C shell, bash shell. So right now whatever we are going to do, that will be on a bash shell mostly. Mostly bash shell is very popular, or C shell is also popular, but mostly we are going to use bash shell. And on top of that, various utilities we will see, that means yum for installation, or in case of Windows we have add and remove, right? In order to install or uninstall softwares. So in same thing in case of Linux or Unix, we have a yum or some other distribution, they have other package management services. So in this way, lots of utilities are there on top of these softwares. Okay. Now Linux distributions. So Linux distribution do the hard work for us, taking all the code from the open source project and compile it and combine it into a single operating system we can boot up and install. So Linux distribution means, again, most of these distributions are open source distribution. And generally, when we are using operating system as an installable package, we get that installable package ready made. We don't need to compile or anything. So that is what this sentence means. But as an end user, when I see we are as a DevOps engineer, we are not going to install or configure Linux operating system. That will be something done by the network administrator in your team. But this is readily available. We don't need to compile, and those distribution gets very handy to us. They are also make choices such as choosing the default desktop environment, browser, and other software. So this distribution, again, there are various distribution, but suppose you want to have specific browser, specific database, and some other utility configure along with that operating system. So there are two things here actually. One is vanilla operating system, and operating system coming with additional utility install on it. So in this way, those various distribution of same operating system available. And even they have categorized, means even CentOS, suppose you want to install as a vanilla CentOS operating system, that is also available. If you want to install with some database, Oracle, MySQL, along with that, such kind of distributions are also available. Most distribution add their unique things such as theme, custom software, for example, utility desktop, environment by Ubuntu. So we will see various distribution of Ubuntu, and probably I'll cover more detail about this point there. So this is what I was talking about. Hardware, kernel, we have various shells, and various users are logged in here. They are running various commands, various utilities, various applications, and that way we interact with hardware and operating system. In the scene, when I say operating system. So if you see at the bottom portion, we have keyboard, mouse, display, audio. These are peripheral devices. These are used by the human interface functions. These are the functions. These are the bottom layers. So these are the hardwares: keyboard, mouse, display, audio. We only audio because speaker will be there, mic will be there. You can include mic here also. Internally, there will be USB port, PCI. PCI means there are various slot. Memory slot will be there. Other slots will be there. So those are PCI slot, right? Then CPU will be there, RAM will be there. Again, RAM has various type, SSD RAM and various types of RAMs are there. So those RAMs will be there. Then these are the storage devices. So a few minutes back, I was talking about volume, right? So hard disk, this is what your hard disk, and network devices will be there. Means Ethernet card, Wi-Fi link, Wi-Fi's devices, hardware devices will be there. So this entire bottom layer is about hardwares. Okay. And now see what is happening at the top layer. Means this is something happening in the backend at the OS layer related with memory. This is something happening with CPU. This is something happening with interdata transfer using some cable connections, right? This is something we are sending user input to the operating system. This is something happening at the hard disk level. This is something happening at the networking level, and definitely there will be interconnection and lots of communication happening between these things when we submit any instruction at the operating system. Okay, so don't get bogged down. I just wanted to give you some idea what is there in the backend when it comes to the operating system. And when it comes to the networking, you can see here we have TCP, UDP, IP address. These are the base level protocol. But on top of this protocol, there are again various protocol like FTP protocol, SSH protocol, in a network file system protocol. So various protocol, and there are various port number actually. If you see this socket programming, so over the network we will send data to specific port number. So those are the things. Again, file system, we will talk a lot about network file system. If you want to make that other machines file system, if you want to expose to network, so that's where NFS protocol will come into the picture, and lots of things are there. I don't want to bog down you people with this diagram, but still, if you have any question, please feel free to ask me that question. And this is the bigger picture again at the low level. What is where communicating, which thread, virtual memory, virtual file system, right? Then block devices, how the data is read from the storage, right? Storage, again, storage has a file system. We will talk about that. So when it comes to the, let me hold on to that point. I'll not take you to that level because you will be bogged down otherwise. So multiple threads are running. Their thread scheduling will be there, synchronization, right? Stop this thread, give the chance to another thread. So all this garbage will be happening behind the scene. Okay. This is again very low level detail of operating system, how they are coordinating with all the hardwares which are at the low level. Now coming to the Linux distributions. So as we saw, there are various Linux distribution, right? Linux kernel. Again, all the distribution, most of the cases they have same kernel, means version could be different, but kernel is different, have own patches of kernel to suit the target audiences. So every kernel, they can come up with their own patches, and according to that, they use it for real operating system. Core GNU utilities means we saw, right? There was a movement related with GNU and they developed some free software. So there are many free softwares available as part of the GNU utilities. Supplemental software means there are generally two types of operating system. One is desktop operating system and server operating system. Okay, so what is difference between desktop operating system and server operating system?